Markus, yeah, you can hear me. Welcome to this talk, client-side machine learning. Angular is all you need. So, the future is looking bright for client-side machine learning. We have Julian Chamond, co-founder of Hugging Face, saying here he's highly betting on it. We have Gemini that was announced a while back, and also Gemini Nano, which is a large language model that is intended to be used locally on a user's device. We had Scott Hanselman say last month, in the future, we're gonna see, in my opinion, local models on Windows, local models on iPhones, where we don't have to send the data anywhere. And we have seen tons of new models and machine learning services being released this last year, but today we're not gonna focus so much about that. Instead, we will stay more within the Angular ecosystem, and we're gonna see what a fantastic framework Angular is to get the most out of client-side machine learning, and how we can address some of the pain points that may come with client-side machine learning. Quickly about me, I'm Markus. I'm a software developer. I live in Stockholm, Sweden, and I'm a co-organizer of the Angular Community Meetup. So, quickly, client-side machine learning in a nutshell. In server-side machine learning, we have this machine learning model on the server, and we send requests from our Angular application to the server, and we will get a response. However, in client-side machine learning, instead, we send down the model to our Angular client, and the model is kept locally on the user's device. And this brings some benefits. First and foremost, we have privacy and security. Our data won't leave the device, so we can use machine learning without having to think about that aspect. We also get the reduced latency, since we don't have to send our requests to some backend at a remote location. We get reduced server load naturally, since we leverage the client's device. And also offline functionality, since we can cache the model on the user's device. We don't actually need internet access at all. So today's project, we're gonna continue building out this app. It's basically just a simple app that streams video from camera, and we will use an object detection library to list the predictions from this video stream. So here you can see me, and it says person 92%. So it believes that it's a person pretty much. Quickly look at the project structure. We have our app component, very simple. In our template, we reference this video component, and we pass down the stream. This stream is just the user's video stream, so nothing else really. Then we have this Cocoa SSD file, and this is where we have added all the machine learning stuff. And I just want to first say that I don't want you to get stuck on the fact that we're using TensorFlow here today. It's one machine learning model that we're going to use, but you can use really whatever you want. It's just very convenient for me during this demo to use TensorFlow. So we import these two libraries, the TensorFlow.js library and the TensorFlow models library, the Cocoa SSD model. That's why this file is called Cocoa SSD. We have a function here, load Cocoa SSD, nothing fancy going on here. We set the browser's backend to use WebGL if it's possible, and then we'll just load the model and return the success status. Then we have this detect method that takes in the model, it takes in the image data that we get from the video. We take the image data and we convert it to a tensor. You can just think of it as a different representation really here. And then we try to take the tensor and we see if we detect any objects in it. And then we just return the predictions. Then we have a Cocoa SSD service. It's just a regular service that implements this object detection interface that we have created. And if we look into what methods it has init model, and we just call the function that we just saw in the Cocoa SSD file, and we set the model. And then here we have a method called request prediction, so you can see here down. And what we do is we're using a subject, and then we take this subject, and if you look here up, you can see that the predictions is derived from this subject. So we listen to the stream of image data, we filter out any values as long as the model isn't loaded. And once the model is loaded, we use an exhaust map to make sure that we only send one request at a time. So we will wait until we've actually got a response, until we'll do the next request. Then we have this object detection token. This is just an injection token, which has the interface that our Coco SSD service implements. We see a factory function here that just returns the Coco SSD service, and we provide this token in root. And machine learning models, they can get pretty old quickly, which we have seen this year. So what is really nice by incorporating ML, machine learning, in this, using this approach, is that you can easily replace this service with a completely different service. And the rest of the app won't even know that you have actually updated your machine learning model. So this is actually something really powerful. Then we have this video component, nothing fancy going on here. We have the template with a video element, and we list the predictions in the form of its class and the score as a percentage format. And then we have the video component class, where we kind of stitch together everything. We have the stream coming from the app component. We listen to the predictions from our object detection service, which is this case the Coco SSD service. And after viewing it, we set the source object of this video to the stream, and we initialize our machine learning model. And then we have some interface files. Okay, let's look at the first issue. Machine learning models can be pretty chunky. And by that, I mean that they can be pretty large. And large machine learning models, they can lead to an increased app loading time, which will eventually increase the bounce rate and lower the conversion rates. And if we look here at the performance, it's not looking great. We have a first contentful paint of 16 seconds. So there's room for improvement. And we've had laser loaded routes for quite some time. They are fantastic in a way that we can laser load modules and components on the routes where it's actually used. So we don't have to use unnecessary components or modules where we don't need them. But we have a new member to the family. And you might already know where I'm heading. We already had a great talk on this. Deferrable views. That's right. A new feature in Angular v17. We defer the loading within a template. And again, Naveen has already delivered a fantastic talk on this, so I'm not going to dig too much into it. But it supports triggers, prefetching, and sublogs for state management. And it's the must-have feature for client-side machine learning. So, let's do some demo. So I'm going to go to Visual Studio, and I'm going to go here to my app component. If you remember here, we render our app video here. So what I'm going to do is I'm going to update this if statement, and I'm going to use defer. And I'll use the word when. So by doing so, we will actually not load this component until the stream is actually set. So by doing so, the initial load won't actually have to wait for TensorFlow to load, for the TensorFlow models library to load. And here you can see that we have this lazy chunk file of 6 kilobytes. So we are managing to load this at a little bit later, which really helps with the initial render. So if we go back to the slides, we can see here that the first contentful paint is down to 7.2 seconds. Still room for improvement, but from 16 seconds, it's a pretty big jump and a pretty large step in the right direction with a very small modification to our code. Another issue we have is that machine learning models can be computationally expensive to use. So, if we see here, we have a total blocking time of 62 seconds. I'm not sure how much we're supposed to read into that, but something is going on. And if we look here into the Performance tab in the Chrome DevTools, we can see that we have a long task here that runs from 8.5 seconds. So basically what's happening is that the browser is being blocked. And I can actually show you this. I'm gonna go back to Visual Studio, and I'm gonna update here. I'll add a hover to our header, And if we go to this here, and I'm hovering this text, you can see, let's see, we're going to refresh it. You can see that it doesn't register the hovering, right? And let's see, the camera does not show up. That's kind of critical for this demo. We're going to see. I won't sweat it. You just have to trust my word on this one. That we are blocking the browser basically. So, oh yeah, there we go. Nice. We're blocking the browser. So if I refresh this page here, you can see that even though my mouse is not over this header, you can still see that it was actually red. And that is because we are actually busy rendering, or we are busy loading this machine learning model, so we don't actually have time to render the UI. And that's a problem, right? We can see here that lots of the time is spent on scripting. So again, the main thread is very worked by doing this machine learning related stuff. But there is something we can do and get straight out of the box with the Angular CLI, and that's ng generate web worker. And not only are web workers great, but they work really well together with RxJS. So we're going to see how we can leverage this and get improved performance. Quickly, what are web workers? It's been around for a while, but the definition here, this specification defines an API for running scripts in the background independently of any user interface scripts. So basically what it is, as previously mentioned, we saw that the main thread was blocked because it did a lot of machine learning stuff, and that's because we only have one thread available in JavaScript. So what we want to do here is delegate all the heavy work to a web worker, and by doing so, we can let the UI instead focus on rendering our application and this critical hover effect that we wanted to see. So what I'm going to do here, I'm going to do ng generate. First, I'm going to generate a new service. I'm going to call it CocoSSD WW for web worker. I'm going to skip the test for now. Don't do that at home. And we see that we have generated just a regular service. I'm going to implement this object detection interface, and I'm going to make sure that we implement all these methods. So these are the methods that we want to this service to have, so we can easily replace them later if we want to find a new machine learning model or machine learning model service. Now we're going to generate our web worker, something like that. I call it CocoSSD as well. You're going to see now that we'll, let's see, going to see now, compare, okay, let's see, I'll take that code. So this code was generated into the file. It actually did not, because I did not save the file, so there was a conflict. But this code gets generated once I write ng generate web worker, and it's basically saying that, you know, it's pretty much showing how I'm supposed to set up this web worker, and it has a safeguard here that if there isn't a web worker defined in the browser, find a fallback plan. So what we can actually do is we can take this condition, and I'm actually going to use it here in this injection token, and depending on if the web worker service or the web worker is available in the browser, we will use this service, and if not, we'll just fall back on the regular old service. So again, really nice way to just leverage injection tokens here. Now I'm gonna use my cheat sheet to save myself some sweet time. So I'll take that code and I'll quickly explain what it's doing. So here we declare our worker and we set it up. We register our event handler for this web worker for the case where the model is loaded, and we set this variable here to model loaded depending on the success event. Then, similar to what we saw previously, we have this request prediction subject, which we here in the request predictions method just emit, and then we take this request prediction subject and derive the predictions that the video component is listening to. Here we return this method, which is just it's a method that just returns an observable that we create from scratch. Again, here we register this event listener that will listen on the predictions, and then we pretty much emit the data in this subscription, and we complete the stream. And then once we have set this up, we will send a request to this web worker. We set it up. The reason why we have this type is because the web worker will get these messages and not really know what it is. So by using this type, we can kind of show the intent with the request that we're sending to our web worker, and then the image data. And we set up this request and we send it to the web worker. And now we have to actually do something here in this web worker. Now I'm gonna go to my trustworthy cheat sheet. I'm gonna copy paste some more stuff, quickly explain what it does. So here we'll basically switch on the type of the requests. So here we have a case for load model, nothing strange going on here. We use the CocoSSD function that we saw early in today's demo. We set the model and we return the message with a success event. In the case for the predict, similar thing, we use the detect function that we have in the CocoSSD file. We create a response and we post this message. So if we now, if we go back to our browser here, and I refresh, and this symbol for my see, I'm not going to spend too much time on it if it takes a little time. Again, kind of have to trust me on this one. Sorry, let's see if I play from the current slide here. Okay, and there you see that our performance have improved drastically. So the scripting looks way better now. We don't spend much time scripting, and again, that's because we delegate all the heavy work to the web worker. And yes, our score looks slightly better. Again, room for improvement, but we have taken a nice step in the right direction. So quickly, what about offline support? We are spoiled in Angular. We'll just do ng-add Angular PWA, right? And what does it do? It adds a service worker to our app, which will help to cache and serve assets offline. So again, quick demo to show this last thing. So we will do ng-add Angular PWA. And in the meantime, I'm gonna go to this cheat sheet and explain what I'm doing here. So we will add a configuration file for this service worker. And what we'll add here is, basically we say that, you see these URLs, please cache them under this strategy that we have set up here, so that it can work even though we don't have access to internet later on. So what I'm going to do here, I copy pasted this code, and I'm adding it to this ng service worker config file, and then I'll quickly have to build this one, because trying service worker out locally, we can't actually use ng-serve. So we're going to use something called HTTP server. I'm just going to verify. We'll see in a second what the dist file will be. Angular is all you need. Okay, so if we go to, let's see if this brings us more luck. I mean, I could try Firefox. The browser gods are not with me today. Well, if we look here, I do believe that I have the app finished here. Yes. So you can see that we hover here. We can hover here, and yet the UI is not getting blocked. However, I do struggle a bit with my webcam. It might be because I've added, this additional equipment here. Yes, trust me on this one that our app will work offline. And let's quickly go to the summary. Yeah, you can see here, we can install the app quickly. We have our app, and if we wait a couple of seconds, we would want to hope to see that the spinning disappears, and let's give it, yeah. Again, I'm not gonna spend more time on this. Again, you have to trust me on this one. I made an app to kind of incorporate all of this stuff. It's heavily inspired by Jason May's PetCam app. It leverages all the benefits of Angular that we have visited today, and it's live on ngpetcamweb.app. You can try it out there. Hopefully your device's webcam is not as painful as mine is right now. And you can also get access to the code here. So the idea of the app is kind of you want to monitor your pet. You see here we selected the pet. It's a dog, and we're monitoring its bowl. It's not working great currently. I'm trying to get focused on the bowl. And the idea is that it's supposed to warn when the dog and the bowl kind of intersect. So now you see the bowl and the dog, the boundary boxes is intersecting. We have an event, and we were able to prevent further damage from happening. Okay, so summary. Today we learned some of the benefits of using Angular to build client-side machine learning using these different approaches. Use deferrable views to lazy load heavy dependencies. Leverage Angular's DR architecture to easily update machine learning models in your app. Use web workers to make your app run smoothly, and use ArcGIS to deal with asynchronous event streams. And finally, leverage Angular's native support for building PWAs. Here are some further resources. And here's a QR of the code if you want to dig into it more. Thank you so much for listening. It's an honor to be here, and I'm really grateful. Thank you.